Hey, good afternoon, everybody. Jim Warren with TXAPA. Glad to have you here today. We're continuing our discussion this month on balanced mix design. Last time we talked about what's happening in Texas. Now we're going to talk about what's happening nationally. Today we've got Dr. Richard Willis with the National Asphalt Pavement Association with us live via Zoom. Richard, how the heck are you?
Doing all right. I'm enjoying the opportunities to connect with a lot of people via Zoom these days, and just happy to talk about balanced mix design, which is something we're pretty passionate about at NAPA.
Yeah, absolutely. As much as people hate Zoom, it really has allowed us to do some things to save a lot of money on airplanes and and still get messages out. And so that's what TXAPA Live is all about. And again, big thanks for having you here with us today. We're going to again continue the discussion on balanced mix design, but let's take a step back just a little bit and kind of talk about how we got here. We've got a couple images we want to show, and one is this, just kind of the history of mix design. So Richard, walk us through this.
Yeah, absolutely. And I have to thank Shane Buchanan from CRH America's Materials for letting me use this slide, which was taken from an Asphalt Magazine article that was written a few years ago. So if we look at mixed design history, we really got started looking at asphaltic type mixtures in the late 1800s. And the first one was really the Barber Asphalt Paving Company, which if you look at what a lot of these designs were, it was a high asphalt content. It was 12 to 15%, mainly sand, not a lot of granular materials, but just a little bit of lime at the end. Then the New York Testing Company and Clifford Richardson developed the next really kind of set of mixes. And if you look at these, they're very kind of recipe specs.
Correct.
I have a certain amount of asphalt, a certain amount of sand, and it's not really looking at how they all come together.
Well, they were patented.
Yeah.
For a while. Yeah.
Yeah, you're exactly right. And so when the New York Testing Company developed their mix, it was really, again, a lot of sand, high asphalt content, and they did start using the terminology VMA a little bit. And so we start looking a little bit at some of those volumetric properties. The mixtures that we're more familiar with and started coming on board were in the 1920s, when Charles Hubbard and Frederick Field developed the Hubbard-Field method, which was, again, a sand asphalt design. They used a 30-blow design with a 6-inch compression test. And they started actually looking at, well, how does this mix perform? There was a stability assessment in this process instead of just looking at recipes and volumetrics. When Francis Sabine developed the design for Caltrans, again, it started looking at how is this mix expected to perform? Now, the challenge with a lot of these type tests at this time is I tested for stability and durability, and it didn't always really relate back to the field performance we were expecting to see.
Right.
But they were looking at more than just, well, what do these ingredients do together? How can it actually help us achieve the goals that we want? When you looked at the beam method, there were some volumetrics involved. Air voids wasn't used eventually, but it produced a little bit of drier mix and it started having some fatigue cracking. And eventually California moved away from this type of design method, though they did use it for many, many years. The mixed design method that was really used the most in the U.S. before SuperPave was the Marshall mixed design method.
Right.
It came from the Mississippi Highway Department, where you made your mixes, you had blows on each side of your sample, and you looked at air voids, VFA, and VMA was eventually added into this. Again, this was a volumetric design, but there was some kind of check for stability and durability. In fact, a lot of QC labs across the country today, you'll still walk in, even though they've been doing SuperPave for 20, 30 years now, you'll find a Marshall press that people are using for some way or another.
Yeah, and you just told me you're a native Texan, and you forgot a real significant history part, in this graph, and I'll blame Shane for not putting it in there, but the Texas gyratory came in around 1939, and I believe TxDOT implemented it around 1945, 46. So right about the same time Marshall took off with the rest of the states. Well, Texas went and did their own thing as they normally do. So just a note in there, and a little bit of trivia.
They did not teach me that in my second grade Texas history class.
We'll work on that.
I'm always happy to learn more about where I'm from. But where most people are today, or at least moving out of, is the super paved mixed design system.
Right.
And I think it's important to realize that and remind ourselves, when the super paved mixed design system was set up, it was originally designed to have 3 levels of mixed design. One where it was just the volumetric, like we see in the majority of the world, or in the U.S. today. The level 2 and level 3 would have some performance tests involved, but the reality is level 2 and level 3 never got implemented.
Correct.
Because if you look back at the tests that they were trying to get as a part of the system, I mean, they were complex. They took a long time, really expensive equipment, and it just never got off the ground. The inertia was too great to kind of overcome, and so people just stuck with, we'll just use volumetrics, because they were trying to really address rutting issues at that time across most of the country, and they started seeing, hey, we're getting performance. We're not having rutting issues. Yeah. But the issue was, I think what's on the right side of the slide is really important, is that if we look at all these mixed designs, what we've done is, as we move from the barber to super paved, what we've continually done is push asphalt out of the mix, lower the asphalt content. So what we saw is, when we had these higher binder content, yeah, that makes sense that rutting may have been an issue. But as we've driven that asphalt out of the mix with either gyrations we chose or some of the aggregates that we have, we've seen the pendulum shift from where super pave was trying to address rutting. Right. Now we see the majority of the DOTs across the country are looking at some form of cracking is their major issue. And it could be from us covering up a lot of the old concrete pavement on interstates across the country and joint reflective cracking. I know that's been an issue some in Texas, partially why you developed the overlay tester there. Right. And it could be, if you're in Minnesota, you're dealing with low temperature cracking or some kind of top-down cracking in a lot of the South and Southeast states. And so what we want to do is start thinking about, well, I don't want to swing that pendulum so far back the other way that rutting now becomes an issue again. And so it's, how do I look at these different cracking or distress mechanisms and actually design to prevent them? Yeah, good point. Good point. I think it's funny that roads are actually one of the few things that we actually design to fail. Yeah. I mean, if you look at you don't design a dam to fail. You don't design a building to fail. And so I think if we look at it from a mixed standpoint, where we're designing these mixtures to succeed, and if we couple that with like a perpetual pavement structural design, right? I think we could shift the mindset of the industry to where we're building something that doesn't have that failure in mind. It's got just that maintenance every now and then to keep things active and keep it moving. And especially as we're looking at, hopefully, massive infrastructure investment, it could be a game changer for industry. Sure, absolutely. I go back and, we've been around a long time. I've been around a long time. Look, even with super pave, even with the volumetrics, we started out with all those different traffic levels from 50 to 125 gyrations, and
And they took Marshall mixes and really squeezed, like you said, they squeezed the asphalt out. And, Texas being, having a different compactor, it already had squeezed a lot of the asphalt out. And what we found out going to super pave has been a transition. Texas, it takes a while to do things. But by moving from the Texas gyratory to the super pave gyratory, we're actually allowing some of that asphalt to come back in. And the geek guys and gals that are into the mixed stuff are going, yeah, that's what we need to do. We need to push more asphalt into these mixes. And I think, the things that you're talking about is designing these mixes to where we're not swinging the pendulum from one side to the other. I mean, the last TXAPA Live with Ryan and Craig on it, we talked about, designing mixes to never have to deal with that, and getting them to be both rut and crack resistant at the same time, and then meeting all those other criteria. So good conversation. Hey, I wanted to move on because you had a really good definition that I wanted to talk about. And here's the definition. Go ahead and let's talk about that just a little bit on balanced mix design.
Yeah, so this is actually the definition that was developed when FHWA used to have their asphalt expert task group, and they had a specific balanced mix design group that was looking into all of this and how to implement it and how to write about it. And this is the definition that they came up with. It was asphalt mix design using performance tests on appropriately conditioned specimens that addresses multiple modes of distress, taking into consideration mixed aging, traffic, climate, and location within the pavement structure.
Amen.
And I mean, there's a lot to unpack in this definition if you really think about it.
Yeah.
And it's going to require both contractors and DOTs to start thinking a little bit differently about how do we design and choose the right materials for our pavement.
Mm-hmm.
Because I have to address multiple modes of distress, and where you are in the country, those distresses are going to look different.
Correct.
Because in Texas, you're probably looking at some type of top-down, reflective, cracking, and rutting, of course, because of some of the heat.
Well, we've got tremendous loads like a lot of other areas are, but the traffic growth when just material coming from the south and coming north, the traffic loadings in Laredo coming up, the traffic loadings out in the Permian Basin are crazy numbers. I mean, we're talking, we used to talk about, heavily loaded pavement was 20 million easels. Now these pavements are 50, 60, 80, 100 million easels, which are way beyond what we ever even considered. And so we have to think differently. I like your thought there. We have to think differently about these things and do some different things that may make people uncomfortable, but we got to build these things from the base up. If we can force, like we've talked about before, forcing distress to the surface where we can handle it, but we only build that base one time. And so we've got to put a lot more emphasis on what's underneath, not the sexy stuff on the top, but what's underneath, and make sure we do that right. And I think by doing that with the conjunction of what you guys are doing, with all the good work that's being done at NCAT, I think we can come up with some really good long life pavement designs or perpetual pavement or long life designs that they're just gonna flat work, and we're not gonna have to worry about it. But we're gonna have to switch gears and do things a little bit differently. And I think that's part of where balanced mix design comes in, don't you think?
Yeah, absolutely. It's really about asphalt's an engineered product, or it should be. It shouldn't
be. Yes, sir.
It shouldn't just us be throwing some things together. It should be us looking at the properties of these mixtures and understanding where can they be used most effectively to drive life. And just this is a little bit of an aside, but I think one of the things that we need to start thinking about in terms of life, I think we need to start talking about it in terms of traffic instead of years. Because as he said, a lot of times we design these pavements to withstand a certain amount of traffic. And if there's one thing that most civil engineers are bad at, it's predicting traffic. We don't know when it's going to come to put a distribution center in or something when we're designing these pavements. And so we actually, I think a lot of DOTs are looking at some of their pavements and going, well, this didn't last 20, I designed it to last 20 years and it only lasted 15, so it's a failure. When in reality, it may have hit the design traffic in 10 because of growth, and it actually lasted 5 years longer than we expected it to.
That's a really good point.
And I think when we start looking at engineering these pavements from a mixed design and a structural design kind of standpoint, we're going to see better performance, but it's also going to be easier to communicate that.
Sure, absolutely. Spot on. Hey,
Yeah,
we've got a couple other slides here. I wanted to kind of just keeping the thing moving along here. I'm obviously the big push on balanced mixed design is balancing the rutting and the cracking. So let's talk about rutting just a little bit. Got a bunch of equipment out there.
Yeah, so if you look at rutting tests, there are a couple big ones that people are looking at. The Hamburg and the Asphalt Pavement Analyzer are really the two that are kind of leading the charge. And it seems to be very regional. If you look at the Southeast U.S., they are very entrenched in kind of the APA style testing. But there is another test that's not up here that seems to be gaining a little bit of ground, especially as people are starting to think about incorporating balanced mixed design in the QA side of thing or in the quality control, quality assurance side of work. And that's the indirect tension done at hot temperatures.
Yeah, we talked about that last time, the ideal RT, I think it's called. Texas worked on Fuji at TTI. At A&M has worked on that, big promoter of that, thinks real highly of that. We're looking at that in our balanced mixed design pilot programs, running that along with our Texas uses the Hamburg. And yeah, I think there's something there. Don't know yet, but I think there's something there.
Yeah, I know that there are actually some counties in Alabama that are experimenting with using the IDT at hot temperatures. I think Don Christensen has done some work with that. And the reality is, if in QA, it makes a lot of sense if I'm going to have to implement these tests, have something don't have to do cuts on, have something that isn't going to require me having a PhD in my QA or my QC lab or trailer. Something that allows that contractor to get the results quickly so that they are not out if they've been paving all day and a day and a half later I get the results and I realize I'm out of spec and then everything's bad.
Right. And I think that's the big power with both the ideal CT once you add in the aging characteristic, and you probably be the next day, but the ideal RT test, if it looks like, if it's working the way we think it's going to work, you're going to know that day. You're going to know that within a couple hours, once you pack that sample and get it to condition and run it. So it's going to be quick. It's going to be something that they're able to turn and burn with and know right away. And I think from a contractor's perspective, that's where they want to know. That's where they want to be. They don't want to find out 2 weeks later that now they've got to take material up. They want to know right now whether it's good or bad.
Yeah, because depending on the job, it may not just, say you're doing a binder course and 2 weeks later you may have covered it up and then you got to take out 2 things.
Yeah.
So
not a good thing.
No,
not a good thing. Hey, let's continue on here. Let's talk about cracking. Cracking seems to be the holy grail of everything. Obviously, in the South, you'd think rutting would be our predominant distress, but in my former job in Florida and in Texas, the predominant distress that we see is cracking. So we've got to get our handle on that. So let's kind of walk through these and talk through these just a little bit while we got some time.
Yeah, I think the first thing that a DOT has to do when they're looking at cracking is really understand what are the specific mechanisms that's happening in your state.
Good point.
If you're seeing fatigue cracking, that may actually be a design issue and not necessarily a mix issue.
Mm-hmm.
I think the predominant things you're seeing are there are a lot of people, a lot of states in northern kind of climates that are looking at the DCT type test, which is kind of that picture in the top right where you make a Pac-Man sample and you kind of pull it apart and you measure it. Again, this is not a test that's going to be easy to run. Well, let's just be honest. Most tests for cracking are not going to be easy to run in a QC lab.
Correct.
Because they're going to require saw cuts. They're going to require some kind of processing to make sure you've got the right air voids. And so they're very time consuming. And a lot of them are complex in terms of the analysis.
Mm-hmm.
You have to do some kind of area under a curve or higher order differential equations to get it. And people are trying to build kind of black box technology to do all that analysis for you.
Thank God. As soon as you said differential equations, I got a searing pain in my brain from a long time ago.
Yeah, I mean, but the challenge is, like, if I get a J integral, which is what the SCB from Louisiana is using, or if I get an IFIT number of 22, or I think Illinois requires you to have like an 8 or between 8 to 10.
Yeah.
I'm like, if I get a 6 as a contractor, it doesn't tell. I'm like, how do I fix that?
Right.
How do I get that up, and how do I make a difference to get back into spec? And so there's going to be a lot of work that agencies need to do in terms of understanding and how do I set different targets. And they need to realize that just because an 8 works in Illinois doesn't mean it's probably going to work in your state.
Correct.
Materials are very, very finicky in terms of how they impact the results of these tests.
Mm-hmm.
And so it's going to take us a little bit of time to kind of find the sweet spot for what materials am I comfortable with, at what level of performance am I comfortable with.
Correct.
And so right now, it's kind of the wild, wild west of cracking tests out there.
Mm-hmm.
And there's some great research going on right now at both the test track in terms of they've got their cracking group experiment, which is looking at how do these different tests actually rank the mixtures, and does the rank line up with actual field performance? And then there's also NCHRP 957A, which is looking at developing the models and basically understanding the robustness of these tests, which factors really influence the test results, and refining these so that we can be a lot more comfortable with them as we're looking at developing specifications. And that project is actually being done by TTI and Fujizao as well.
Yeah, so there's a lot of stuff going on with all this. There's a lot of, was that the old thing, what's behind the curtain? There's a lot of activity going on. So let's I wanted to kind of, before we run out of time today, I know we could talk about this for an hour, but I wanted to talk a little bit about approaches, because that kind of gets with definition. I know when we first started the BMD effort here, it actually started before I got here, but when we started a balanced mix design working group consisting of contractors and TxDOT and agency folks, and starting to really look at the results coming out of here, it's like, well, what is BMD to you? And we've talked about that at the last TXAPA Live and kind of where we're going. So you've got a good slide here, kind of talks about different approaches. The first one I would consider kind of the belt and suspenders approach. And the last one is, I'd consider that maybe the Wild West. Yeah. So talk to me about it.
Yeah, so there are 4 approaches that people are taking right now to balance mix design. The first is what they call volumetric design with performance verification, which means I have to meet volumetric requirements, and then I'm also going to say, oh, at the optimum binder content, you have to meet these performance tests.
Right.
I kind of call it the little Debbie school of mixed design, because you follow the recipe, someone QCs it, make sure it tastes good, and you don't alter it. You know exactly what you're going to get. It's not creative. It doesn't allow you to innovate at all. It's what you see is what you get. And really makes it, I'll be honest, it makes it a little bit life harder for the contractor, because you've taken a target, which may have been initially this big, and now you've squeezed it down to this big in terms of adding on those additional performance tests. So there is increased risk for the contractor at this level. Okay. But I also understand that many states probably like this idea at first as they get comfortable with it.
And that's where Texas starts. That's where we're at right now, doing our pilots. Yep.
Yeah. And I think eventually we need to be encouraging people as we get more familiar with these tests and understand them. Let's move on from that. The next one is the volumetric design with performance optimization, which is kind of how I call it the Amy Willis School of Mixed Design. You take a recipe, but if it doesn't taste quite right, you tweak it a little bit. You add a little bit more seasoning here or there. And really the only thing I'm doing is I'm tweaking that binder content to either fix a rutting or cracking problem that mix might have. But again, very little innovation. It's taking what you see and just adding a slight alteration.
Yeah, my wife's a baker, and I can tell by my waistline. But I remember this was when I worked for Napa years ago and lived up in Maryland. She was making a pecan pie one day, and she had a recipe down, and man, she makes a good pecan pie. But I went in there and I threw a handful of chocolate chips in there, and she about killed me. But it actually tasted pretty good, and it took her a couple of years to give me credit for it. But she still makes her pie the way, and I leave her alone when she's baking. And we've been married 34 years, so I kind of figured that out. So, but that's a good analogy. That's a good analogy. So what's number C? What's C?
So this is the performance modified volumetric design, where I'm still trying to look at performance tests to optimize the mixed component and kind of verify that the volumetrics work.
So you're kind of doing it backwards from A.
Yeah, a little bit.
Yeah, okay.
But ultimately, D is where we want to end up.
Right.
So C gives you a little bit more innovation.
Mm-hmm.
But if performance design is where we want to go, it's ultimately about, I don't care what you put in this sucker, just make it work.
Right.
It's about a contractor being able to look at the field of materials that they have and the additives that are available to them and the different types of binder and even different recycled materials, and find something that's going to perform.
Good deal.
As we were talking earlier, it's like you don't go into a great barbecue place and tell the chef, here's how I want you to cook this for me. You trust the person who knows the beef and knows how to cook it, and let them do their thing. And I think this is where we're really going to see innovation occur. I think it's going to be good for both the DOTs and the contractors if we can get to this place.
I agree.
Because if you look at each of these levels, the degree of strictness goes down, which means innovation can go up, which means I can use new materials that may improve performance, while basically coupling it with something that can also reduce cost.
Sure.
So this is where ultimately we want to get. And NAPA's Pavement Economics Committee, which TXAPA is a part of and helps support, worked on trying to gather a lot of information on what states are doing, and putting a kind of a balanced resource mixed design report together, which I guarantee you not many of y'all are going to read, but also a website that you can go to and see what states are doing, and it's updated. So like you see on this graph or this chart, where are states right now? And you see that the majority of people who are looking into this are firmly kind of in that approach A. There are a couple of states out there that are looking at a combination of A and D, but there's still also a lot of states that are like, I don't know where to start with it.
Well, I think that's, I think you got to start somewhere. And I think if you start with the known and then you kind of work your way through and kind of add things on in the process, then you can start to explore. And I know you share the same sentiment I do, is at some point, if we start down this road, at some point you gotta let loose a little bit once you develop some confidence in your system, and you say, okay, now I want you to go ahead and let's see how we can innovate. And that's always, I think, the thing that's in the back of my mind. I know what's in your mind. And we want to make sure that if you start at A, I don't want to end at A. I want to start at A, and then I want to, over time, as we build confidence, work our way into some of these other areas. And I know that's where Texas is doing. We talked about that last time. A lot of states are still, I mean, look at the map. A lot of states that really haven't officially done anything. I mean, they're probably working on stuff, but you got a third of the states maybe that are involved.
Yeah, there are a lot of states that are looking at it, and they just haven't decided kind of what path they want to go down yet. And I kind of reckon volumetrics, to me, when we're looking at balanced mix design, are kind of like training wheels. While we're learning and while we're developing the skills to have confidence, they kind of keep you upright. But eventually, you know how to keep your balance. You know what's expected. The training wheels come off, and let contractors ride.
Good point. Really good point. Hey, we're starting to run out of time here. I want to make sure you've got a couple things we want to talk about before we pull the plug here. So let's kind of start wrapping this thing up here and go.
All right. So just a few things as we close. I think we have to understand that this is not going to happen overnight. It's going to take time because you've ultimately got to see if these tests actually do predict performance in the field. Because if they don't, it's all moot. And we're doing all this for no real reason,
right?
Which means it needs to be collaborative. The DOTs understand what their mixed design approval process is like, but they don't necessarily always understand what a contractor's abilities are and what they are capable of doing either in the mixed design process or in the QA world. And so conversations need to happen so that once something is developed, it is actually implementable. And it's not something that isn't feasible.
Yep.
I think ultimately we have to keep our eyes on performance. That's the whole reason we're doing this, is to make sure our mixtures perform. And if there are things that are getting in the way of that, we need to get rid of them instead of adding more on and making things harder. So don't stifle innovation. Don't keep on adding more and more and more on. Let us focus on performance and let us understand our materials and how we can get there.
Yeah.
And I think the other thing is we don't need to forget about moisture damage.
Oh, no.
We've kind of talked about it as a pendulum, but it's really kind of a 3D pendulum with moisture damage on another side. And we need to make sure that whatever we do, we're not opening up a door for another issue to occur. And so
agreed.
Let's make sure that we're looking at that. And on the bottom of this slide is the address of our Balanced Mixed Design Resource Guide. And I invite you to cruise around that. It's got information on all the different performance tests out there and where states are and what they're evaluating.
Excellent. Well, maybe we can put that in the link with this once we post it on YouTube. So, hey, awesome. You got one more thing coming up. Go ahead and what's coming in the fall?
Yeah, shameless plug for the National Balanced Mixed Design Implementation Conference that NCAT is putting together, and it's actually being run through the National Cooperative Highway Research Program. It is really going to be designed to be an open dialogue between contractors, researchers, and agencies on how do we implement this? Where are we? How do we implement this? And how do we move this forward for the good of everybody? I believe it's free. It's tagged on to the backside of AAPC.
Okay.
So if you're coming to that, stick around for another day. But if you can't attend, I think there is planning on being kind of a hybrid or virtual option.
Good deal. Good deal. So it's not going to be all geeky out. It's really kind of on the practical side of how do we get there? How do we get from A to D or A to Z or whatever, and all the things that we've got to do to build that confidence that you've talked about, that Ryan's talked about, with these designs and with these tests to make sure that we're getting what we're paying for, and we're building good asphalt. You know, I mean, that's the ultimate goal, right? We're getting the performance out. So closing remarks, Richard, I appreciate you being here today.
Thank you very much.
All right. Hey, brother. And need you come back down to Texas, and we'll go back to San Antonio and we'll take you to lunch at a couple places, and or at least get you some good barbecue.
I'm all for that. Most everywhere else I've lived, barbecue is pig, but I miss the beef barbecue.
Yeah, we'll get you some beef ribs and some good brisket. I've found a couple places, shall we say. So, hey, Richard, thank you so much for joining us today. This kind of wraps our July series on balanced mix design. We talked about what's happening in Texas. Now we've kind of talked about what's happening nationally. A lot of stuff going on, really, really good work happening along these areas. So stay tuned. Next time, we're going to take a couple weeks off. We're going to go on. If you saw the preview slides is coming in, we're moving our TXAPA Live to the 2nd and 4th Thursday at 3:00. And so we haven't announced our fall series for August yet, so stay tuned. You can always go to TXAPA.org, TexasAsphalt.org, and sign up for the email list, and that'll get you on there. You can check out our newsletter. So, in the meantime, thank you so much for doing what you do. Let's continue to make good asphalt. Let's be safe out there, and ever forward, everybody.